So we are going to talk about CloudFormation today. I am Amit, and I'll be talking to you for the next 1 hour. I have around 18 years of industry experience, and most of it is on DevOps and very lately cloud as well. So I've worked on the length and breadth of DevOps and the tools that are involved in DevOps. Cloud is my favorite, along with Kubernetes. So I'm going to talk to you about CloudFormation. All right. So I'm going to provide a high-level introduction. All right. So we are going to have an introduction on CloudFormation. Then we'll talk about what's the need for CloudFormation and some demonstration. Right. And at the end, we'll have around 10 minutes of Q&A. Okay. All right. Let's talk about why do we need CloudFormation and what it is. So let's start with a problem statement. Let's say you are a cloud engineer and your responsibility is to manage infrastructure, right? When I say infrastructure, it could be databases, it could be virtual machines, it could be app services, it could be your Kubernetes clusters, it could be anything, right? It could be your pipelines. It could be anything. Let's keep the services in the context of only AWS. Let's say you have this cloud engineer is supposed to manage only AWS infrastructure, right? And let's say you have a team which uses a set infrastructure for their testing, right? So somebody comes in the morning at 9 a.m. and they perform their testing activities till 5 p.m. Right? This is a time that they have identified for doing Q&A on some application, right? So a team is developing a web application and QA team wants to test that application and they test it every day from 9 a.m. to 5 p.m. Right? 5 p.m. they go back home, nobody is testing anything, and nobody's testing anything till 9 a.m. the next morning, right? Now, for doing the testing or the Q&A, you need some infrastructure on which the application would be running, right? So let's say it's a bit of a complex application. So you have a couple of VMs on which the application is running. Then you have a load balancer in front of the VMs. So there you go with the VMs, and you have the load balancer which talks to the VMs, and both the VMs have some database at the back end, right? It could get much complicated, but it's the simplest example that I have taken. So the QA team accesses the application via the load balancer, and the application is deployed here, and that's where the testing happens. But between 5 p.m. to 9 a.m., this infrastructure is not needed, although it continues to exist and the company has to pay for it, but it's not required, right? Can we get rid of this infrastructure every day at 5 p.m. and create it again every day at 9 a.m.? Now, it can be done, but this guy will not like it, because this guy does not want to, just have this workday involving of creating infrastructure and destroying infrastructure and then creating it again, right? Now, you want to create identical infrastructure every day. So you want to destroy it and create it, but it has to be in the identical state every time. Every morning, you want to have the infrastructure ready for you with the same IP address, same virtual machine configuration, same applications installed, same databases, and everything same. Right. So how can you achieve this? So this can be achieved if this user, instead of manually creating the infrastructure, if the cloud engineer kind of automates it. Now, how can a cloud engineer automate creating infrastructure? The cloud engineer can use a technology called infrastructure as code, right? So instead of logging into the AWS portal and then going to the individual services and creating VMs, creating databases, creating load balancers, instead of doing that, you can write a piece of code which contains the complete information of your infrastructure, right? Which VM to require, what should be the name of the VM, what should be the size of the VM, what should be the availability zone and region of the VM, and everything, right? Similarly for databases, for load balancer. All the configuration for the infrastructure is defined in a piece of code or a configuration file, right? And this developer, this cloud engineer can write this file. The cloud engineer is the author of the file. And this file can be subject to an engine which can understand this file and can result in the required infrastructure, right? Which is, let's say, something like this. So every day morning, the user is going to take this config file, give it to this engine. The engine is going to talk to AWS and create an infrastructure which looks like this. And every day evening, the user can take this config file, give it to the engine, but say, hey, destroy everything what you created in the morning. And then it can manage the infrastructure by deleting it, right? So write one configuration file and create an infrastructure again and again, right? Now, this way of working is called infrastructure as code. You write a piece of code, feed it to your um, infrastructure as a code engine, and you get your infrastructure at the end, right? There are various engines available. You must have heard of Terraform. Terraform is a not open source, but free to use with some limitations, infrastructure as a code solution, which allows you to write your infrastructure or define your infrastructure in configuration files and can get your infrastructure up by talking to the cloud providers. There is another solution, which is AWS specific, which is known as CloudFormation. Okay, CloudFormation. So this is developed by AWS, and this is used specifically for AWS, right? So what does CloudFormation allow you to do? It allows you to define templates. It allows you to define templates, which are nothing but the infrastructure as code files, which contain infrastructure details. Right? So it allows you to have templates, and these templates can be used to deploy your infrastructure as and when required. So you can take one template, and let's say this template contains one load balancer, two VMs, and two databases. Right? This template contains that. Now you can take this template and feed it to the engine like Terraform or CloudFormation. So feed it to this engine and you get your actual infrastructure. Right? And what if you have 10 people who are running the testing? You may need 10 different sets of the infrastructure. So from the same template, you can create multiple sets of this infrastructure here. Right? So you can get multiple set of such infrastructures. Right? These are called stacks. So let's say this is called stack 1, this is stack 2, this is stack 3. From one template, you can create multiple stacks of the same infrastructure, multiple copies. with different specifics, like this load balancer name could be different, this load balancer name could be different, and that can be configured. Okay, so this, so first is template and the second is stacks. All right, this is what CloudFormation allows you to have. Now, CloudFormation files or these templates are plain configuration files, which can either be written in JSON, which is JavaScript object notification, or YAML, which is yet another markup language. Okay, so what happens is you open your editor and just write your JSON or YAML. So what do you write in the JSON or YAML? Just give me a second. Right. So in this JSON file or YAML file, there are multiple specifics that you can define. You can define the description of this template, right? You can define metadata of this template. You can define parameters, yeah, conditions, resources, outputs, and a couple of other things. So these are the specifics that you can provide in the template. So when you write a template, you can give it a description, right? For example, some introduction. If somebody wants to know what this template does, they can read the description. You can give some metadata, for example, who's the author, which company it belongs to, when was it created, license information, things like that, right? You can define resources. So what are the AWS resources to be created? For example, all these, your load balancer, your VMs, your databases, everything will be defined in the resources. Now, when you define the resources, you can make it configurable. For example, in the resource definition, you can say, hey, you can create a load balancer, but the name of the load balancer should be passed to the engine along with the template. So when you pass this template to the engine for creating the instances or creating the infrastructure, along with this template, you can also pass some extra variables or parameters, right? These parameters can be passed by the engineer along with the template to customize the stack, to get a customized stack. For example, in the resource, you can define there has to be one load balancer, one virtual machine, one database, but then you can define parameters and take input from the user while running this template that, okay, what should be the size of the database? What should be the configuration of the VM? What should be the IP address of the VM? And what should be the host name or elastic IP of load balancer? So all those details can be externally provided, right? You can also have conditional execution where you can say, if this condition meets, then do this or that. And in the outputs, you can define what output should be printed when you create the stacks, right? All these configurations, all these declaratives in the template are optional. You don't have to define all of them except the resources. Resources is a mandatory configuration that you need to write in the templates. You can choose to not define any description. You can choose to not make it parameterized. You can choose to not provide any metadata, but you have to define at least one resource. Okay, all right. So how do you run this? How do you create this? Where do you store it? Where do you store the temple? How do you feed it to the engine? How do you run it? How does it work? So when you define a template, when you define a template, you can store it either in, maybe I should make it smaller. You can have a Git repository, maybe on GitHub or GitLab or whatever, and you can have the template here, right? Or you can store it in an S3 bucket, right? Or you can upload it from your computer. So you can go to CloudFormation service on AWS and provide your template from here, from either a Git repository or S3 bucket, or upload it. And then when you give it to CloudFormation, so from any of these sources, you can give the input to the CloudFormation along with any parameters that you want to pass, and then you get your infra. Okay. Now, how do you write this? This template. This template which you can store at any of these places, right? How do you write this? It's in JSON or YAML. So you can write manually, write all your JSON and YAML data, or you can use CloudFormation Designer, which is again a GUI-based tool provided by AWS, which allows you to create your Terraform template with a GUI method. Right? Maybe it's a bit of too much information for you as of now, but let's take a look at the demonstration, and then maybe it will make more sense. All right. So let's go to CloudFormation. So if you go to AWS and if you just look for CloudFormation, you will find CloudFormation here, right? If you click on it, you will land on this page. This is the CloudFormation homepage, right? You don't have to pay to use CloudFormation. You just have to pay for the resources that you create via CloudFormation, right? So you can see here in the CloudFormation section, it says stacks. So what are the stacks that you have created using CloudFormation, right? I haven't created any stack. So let's create a stack. Now, when I go to create a stack, it asks me, all right, template. Is the template ready? If it is ready, then either give it the S3 URL or upload the template from your computer or sync it from Git repository. Okay. I don't have a template ready, so I can say use a sample template. There are some sample templates provided by AWS. For example, creating a LAMP stack, which is Linux, Apache, MyPHP, and PHP. Right? So you can see a template for this and then modify it later. So I can either use a sample, or I can say I want to create a template in Designer. Right? Let's take a look at this. Let's click on create template in Designer. And you can see here, there is a designer created here. Now it says to start building your template, drag resources from the resource pane. So let's say I want to create a couple of EC2 instances, virtual machines. So on the left-hand side, there are resource types. Let's say I want to create EC2 instance. So I scroll down and I find EC2. I open it, and these are the resources that can be created. And if I come down, I find instance, right? I click on instance, drag it, and bring it here. So this is my EC2 instance. And you can see here, it is in the real time generating this template. The font size may be small. Maybe let's see if we can increase the font size. I can increase a bit here. So the problem is I lose the. Okay, anyways, so this is the instance created, right? So see this, it's generating a template, right? The default language is JSON. You can choose to generate it in YAML format as well, right? Let's stick with JSON as of now. And if you click on template, you will just see the raw template here, right? But let's go to components as of now. Okay, so it says define resources, and there is one resource called this. I can give it some name, for example, my virtual machine 1, right? And it says design is out of date because, hold on a sec. Yeah, it's out of date. Let's refresh it. Yeah, now you see here, there is this virtual machine. It's called my virtual machine 1, and it is of type AWS EC2 instance. Right? And that is it. I can add one more resource. Let's go to instance and create one more resource. And let's call this resource as this resource is called this one. So I call it as my VM2. I refresh this also. This is my VM2, my virtual machine 2. And you can see here now, I get configurations, or I can select which resource I want to work on and work on it. And you can see the template is being generated. So these are the resources that are being generated, right? And there is my virtual machine 1, and then there is my virtual machine 2, right? Now, if you see this template, I'll just copy it and put it in an editor. Right? So this is the template that has been generated till now. And if I collapse it and see the top level items, there is resources, there is metadata, and then there is AWS template format version, right? If I go back to my drawing, I told you that you can have all these top level configurations, metadata, conditions, resources, parameters, right? So you see something of same metadata, resources, and things like that. There is also one more thing called AWS template format version, which defines what are the capabilities available in this template. So based on which version we are using, we can have some keywords. If we use an older version, we may not have those keywords also, right? So this is the latest acceptable version, so it works fine. Although it may seem very old, but it works fine. Now you can see here the metadata, it was automatically added by CloudFormation, right? You can remove this metadata, but it is helping CloudFormation to create that GUI kind of thing. If you want, you can remove it. It's not going to impact your template because it's just metadata. And then you have resources. So you have two resources. There is my virtual machine of type AWS EC2 instance, and there is my virtual machine, my VM2 of type AWS EC2 instance, right? Now we can define some properties for this AWS EC2 instances, right? How do you define the properties here? So Let's go here. So we do not have. So, for example, we can specify what is the security group for this AWS instance. We can specify which subnet it should be. We can specify which image it should use, right? Things like that. So it's not generating here for some reasons. All right. So yeah, you can use it like this. Now, if you want to specify more properties um, for your template or for your resources, let's maybe go to the documentation. I don't want to go to this documentation. I'll just say template anatomy, and let's go to resources, and you define resources just like this, right? And there is a detailed instruction on resource and property type references. Okay, so we were creating EC2 instance. Let's look for AWS EC2, and in that we have instance. So these are the properties that you can define for AWS EC2 instance, right? You can define the affinity, or you can define host ID, or many things. I'm looking for image ID, right? You can define image ID like this, image ID and the value, right? You can also define instance type. For example, you want to create a M5 2XL or R6 IDN 12x large or whatever, right? You also have the smaller ones like T2 micro, T3 micro, and things like that. So you can define the instance type as well. So let's do that. Let's quickly copy this image ID and instance type format configuration, and I'm going to define it here. Right. I couldn't copy it. And here you go. I don't want this property. This goes away. And I can define the image ID here. I can define the instance type here, right? So I can say T2 dot micro, and the image ID should be, let's see what could be our image ID. Let's figure it out. This is the image ID. So I say I will use this image ID, right? And I will do the same thing for the other VM. And this time I say this one should be T3 micro. right? So I'm writing my configuration and I have two resources. One is, both are VMs. One is T2 micro, one is T3 micro, and they are using specific image IDs, right? Maybe I'll choose a different image ID for that one. This one, let's say, is based on this image ID. Different image IDs and different instance types. So I have a little bit, a very basic template already ready. Let me remove this metadata. And that's it. I can remove the metadata from individual resources as well. Right, so this is a very small template ready. Virtual machine, type is this is the property. Virtual machine 2, type is this is the property. Right, I will copy it and I can either save it or put it in an S3 bucket or put it in Git repository and then sync it from there. I'm just going to save it somewhere. Let's save it on my desktop. And let's say CloudFormation and save it. Right? A simple small template. And I go back to my CloudFormation. I don't need designer anymore because I have my template ready now. Let's go back. Let's go to CloudFormation. Now we are back at the create stack stage. Now the template is ready and I'm going to upload a template file. Choose a file. This is a CloudFormation, right? It's in JSON. It's going to upload internally to S3 bucket. So you can see here S3 bucket has been created and click on next. I can generate the visualization for this template in Designer also, but let's ignore that for now. Click on next. It says line 9, column 5. There is a issue. Line 9, column 5. Okay, maybe it's because these are all tabs. See? See again. All right, so that was okay. So looks like tab was not required. Okay. Stack name, I say SkillUpRight demo. Click on next. Must contains only letter, numbers, and dashes. So I say SkillUpRight dash demo. And then I can give it some tags. I can give it some permissions or something like that. There are some options now. If the stack creation fails, what should be done? So because there are multiple resources in my template, I can either choose that preserve successfully provisioned resources. So for example, if there are two resources defined in my template and one of them is created and one of them fails, what should AWS do? So I can say whatever is created, let it be. Whatever is not created, well, we'll figure it out. Or I can say roll back all the resources. If even one failure exists, undo whatever you have done till now. Okay, so I can say roll back my resources, and there are some advanced options as well. We can define rollback, how it does, and things like that. But that's okay. We are not going to cover that. And click on next. And now you see it's a review place. So template is ready. Template was uploaded here, and stack name is this one. These are no parameters as of now. Stack options. I have not given any specific things, so everything is default. And click on submit. And now you see creation is in progress. And you can see the events here, what is happening. So first is creation in progress. If I refresh, there are some more things here. So my virtual machine 1 creation in progress, virtual machine 2 creation in progress. It was still creation in progress. Then you see virtual machine 2 creation is complete. If I refresh further, let's see what happens. Virtual machine 1 creation is complete. And finally, this complete stack creation is complete. So from my template file, I could create instances. So if I go back here and go to instances, I should see 2 instances created. If I look at this particular instance, it is based on if I can see the AMI ID. So it is based on this AMI ID, which is 3BC, and we also provided 3BC AMI ID, and the other one would be a different one, right? This is 60C6, and this is what we chose. So there are 2 virtual machines now created based on the template. I can go back to the stack here, and I can say create one more stack, right? Again, I'll upload the same template and just create a new stack, right? So this is how I can create resources and then at a scale. I can define 10 resources and create them all together, just like that. So every day evening, I can say, hey, take this stack. So go back to this problem that we were talking about, right? This poor guy had to create this resource every day morning and delete every day evening. So now since we have a template, this guy can at 5 o'clock just select this and say delete the stack. And this stack deleting will delete all resources. So I click on delete and delete is initiated. And you will see there in the instance list also slowly it is shutting down, and then it's going to get rid of the instances pretty quickly. And the next morning, he can click on create stack and create it. Or he can automate this creation and deletion as well every day. Right? You can also put in some parameters in this template. So I'm just going to demonstrate about parameters and then we'll wrap this up. Give me a second. Right. So I can create a block called parameters. Parameters. Right? And in this parameters block, I can specify some parameter which I want a user to pass to this template. So I can say, for example, instance, let's say instance type. Right? This is a parameter that I'm defining here. And now I can give more details about this parameter as well. For example, some description. And I can say, okay, this parameter is for provide the instance type for VMs, right? What could be the type of the parameter? That means what kind of value can be provided. So the value is string. So this is a string type parameter. That means you can pass a string value to it. What is the allowed values? Right? I can tell, hey, you can only pass values between these. So it is going to be an array, right? So I'll say maybe t2.micro and t3.micro, right? So only between these two you can choose. And the default value is, what is the default value? The default value is, let's say, T2 micro. Right? So I define one parameter here. And what I can do is, I can use this parameter in some resources. Right? For example, in the virtual machine, I can say instance type. For the instance type, yeah, refer to the parameter, this one. So get the value of this parameter and use that reference value for this particular property. So whatever is defined in this parameter should be used here. Now I have given a default value, but this can be overridden. So let's see how it works. I'm going to save this. And now let's say create stack. Template is ready. Upload the template. Choose file. CloudFormation. So everything looks okay, I guess. Okay, there is a template error line 9 column 4. Let's see. Okay, because there are tabs. Come on. Why the default value is tabs? Hopefully should be okay now. Template format, parameter name, instance type is not alphanumeric. Okay, there is a problem. I cannot give underscore. So I'll just say inst type. Inst type. Yeah, do that. All right, next. Okay. So because I changed the name of inst type, I need to use the same name here. Next. Now it's okay. Yeah. So stack name is, let's say, another stack. And this time it asked me, there's a parameter inst type. It says provide the instance type for VMs. And it's coming from here, right? Inst type, provide the instance type for the VMs. And it gives me an option. Choose from these values. So T2 micro or T3 micro. By default, it has chosen T2 micro because that's the default value. So I can say next and nothing else. I just say next. I go with the default value. So you can see here somewhere there will be parameters. So there's a parameter called inst type. It has taken T2 micro as the value. And then I can click on submit. And it's going to create the virtual machines with that particular value. Right? I can click on submit. It's going to create another stack. I can create a new stack with new resources. I say upload the template file. There is the template file. Next, I give it a new name. That's the stack. This time I can change the template, so T3 micro, or change the parameter. Next, and I can now create a resource or stack. In that stack, this particular virtual machine will be of type T3 micro. So now I can customize things, right? I can create more resources and customize. For example, I can choose different availability zones, different subnets, different VPNs for this. Make sense? All right, so this is all I wanted to show. We have already seen how do we, delete a stack. So this stack is creation is complete. If you go to instances, you can see here there are 2 new instances created from the stack, and I can just say delete this stack. All right. So this is how you can manage your infrastructure on scale. Now there are a lot of things you can learn for CloudFormation. 1 hour is not enough, but this session was supposed to be, give you an introduction to the um, CloudFormation and CloudFormation templates and stacks and everything. Hopefully, you can use this information to learn more on CloudFormation if you're interested, or maybe at least you are able to understand some CloudFormation stacks if you see some. So let's open the floor for questions, and after the questions, we'll wrap it up. You can use the Q&A section for questions so that I'm able to see the questions and everybody else can also take a look. All right, there's a question. How is Terraform different from CloudFormation? So CloudFormation is very, very specific to AWS. You cannot use it to create resources on Azure or GCP or anywhere else. If you use multiple clouds, you will have to use their own specific templating solutions or infrastructure as code solutions to manage the infrastructure. Terraform actually allows you to create or manage infrastructure on any cloud provider. So that's the one solution, one difference. Second is Terraform is by a third party. It's not a first party solution. And I would say Terraform is much easier to learn. But CloudFormation is very, very powerful. So yeah. Thanks for the question. Maximum number of resources that you can create? Is that the question? The maximum number of resources will be based on the technical limitation of your AWS account. There is no limitation from CloudFormation. All right, question. Is CF declarative like Terraform, and can we call different templates from CF to Ansible or vice versa? Of course, it is declarative because we have written the configuration file. You can call the template from Ansible, yes, using CloudFormation, but I would say it is tricky, so should not mix and match. Terraform is also written in JSON. Terraform is not written in JSON or YAML. Terraform can be written in JSON, yes, but this most popular language is HashiCorp configuration file or configuration language, which is developed by HashiCorp. It is similar to JSON, but it's quite different from that. How AWS CLI is comparatively with Terraform commands. You're seeing how CloudFormation is comparative with Terraform commands. I have already listed down the comparison. I think I answered this already. For production purpose, can we use this? Of course, yes. It is used heavily in the industry. So for production, you can use this. What are some common mistakes to avoid when using AWS CloudFormation for IAC? Common mistakes to avoid, I would say, circular dependencies. You can create dependencies for resources. Like first, you can define a sequence of creation of resources, right? First resource one should be created and then resource two should be created. But if you say first should be created after two and two should be created after first, then it's a circular dependency. So you should avoid that. Try to avoid hard coding any strings, especially the strings which are being repeated. For example, if you see many instances with T3 micro, so instead of writing T3 micro everywhere, store it in a parameter and use that. So these are some things which you can pay attention to. This is used to create infra. Can we establish connectivity between two resources by using CloudFormation? You can create whatever you want, which is provided by AWS. So you can create virtual networks, you can create groups, you can create subnets. So whatever you can do from portal, you can do from IAC, from CloudFormation. Does Ansible is also IAC? Yes, Ansible is also IAC, but it's for the configuration of the servers, not for creating new infrastructure. EC2 instance creation, EKS client, how will be advantage when using Terraform? The question is very difficult to understand. EC2 instance creation and then EKS client. These are two different things. How will be advantage when using Terraform? Please rephrase your question. I'm not able to understand it. Thank you. Is Ansible also IAC? Yes. Is it possible to modify existing infrastructure? Yes, you can. You can import existing infrastructure on to the template by providing the ID of the infrastructure. Yeah. And then you can, if you write a different code than what infrastructure already exists, then it will be changed to what is written in your template. Okay. All right. So thank you. Thank you very much for your time. Thank you for the questions. And hopefully you enjoyed the session. It was, at least it brought some insights to your understanding of AWS. And I'll see you in the next one. Thank you. Have a good day. Bye.